So here, just as a recap of exercise 12A, we have a bag contains 5 blue, 8 red and 7 yellow marbles, so 20 altogether. Decide whether these statements are true or false. The probability of picking a yellow or red is very likely. Well, if you think a yellow or red, so a yellow or red, that would mean 15 out of 20. So it is probably true. It's very likely. It's 3/4, 0.75 chance. So yeah, 3/4. I think that's very likely. Random means the outcomes are predictable. Well, that is false. If it's random, it means that there's no decision made. It's completely by chance. You're not thinking about it. It is impossible to pick a green marble. Well, the choice of marbles is blue, red or yellow, so it is impossible to pick a green one. A probability scale will show the marbles in colour order. Well, no, that's not true. The probability of picking a blue is likely. Well, 5 are blue, so 5 out of 20. So the probability of picking a blue is 1/4. So that's not right, is it? It's unlikely. The Sorry, that was right. The probability of picking a blue or yellow is even. So 5 add 7 will give you 12 is even. So it's not a half, is it? So that is false too. There are 20 possible outcomes for picking a marble. Well, that one is true. There are 20 different possibilities. Picking a marble out of a bag is an event. That is true. So now we're going to look at what happens when two things are involved. So how could we write down all the different combinations when rolling 2 6-sided dice and then finding their sum? I'd like you to think about that for a minute before going over to the next slide. Well, we could use what we call a sample space diagram, where we have, going along the top, all the possible outcomes on the first dice. So we can throw a 1, 2, 3, 4, 5 or a 6. Or here we could throw on the dice 2 going downwards. We could get a 1, a 2, a 3, a 4, a 5 and a 6. So this is what we call our sample space diagram. So it's a sample space diagram. You might hear some variations of that. It might just be called a space diagram, but here a sample space diagram, and we were told that we needed to work out the sum. So we would add together, we could have 1 and 1, which would give us 2. We could have 1 and 2 here, which would give us 3. Or we could have 4, 5, 6, 7. So I'd like you to copy out the question on the previous slide. I'd like you to draw this sample space diagram and complete it. And pause the video while you're doing that. So what you should have ended up with is this sample space diagram here with all the possible outcomes here in the body of the table. And there should be 36 different possible outcomes. So the question here is, suppose we roll 2 fair dice, so they're not biased, they're fair. Each of the numbers has got the equal chance of landing on a 1 as it does a 2. And then we're adding up the scores from the 2 dice. So the probability that you have a total of 10 from here, if I look in the body of the diagram, so here a total of 10 would be here. So there are 3 possible combinations of getting 10 out of a total of 36, because we've got 36 numbers here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 36 outcomes. So the probability of getting a total of 10 is 3 out of 36, and we can cancel that down to 1/12. Now B says that the total is at least 10. At least 10. So that means you want a total of 10, 11 or 12 or more. So at least 10 would be these numbers here. And we have 1, 2, 3, 4, 5, 6 possibilities for B. So the probability at least 10 would be 6 out of 36. We'll cancel down to give us 1/6. So for part C, the probability that the total is at most 9 so that means you can have anything less than 9 and including 9. So that would be all of these numbers here in the table. So that would be 1, 2, 3, 4, 5. Maybe the quicker way, if it's at most 9, would be to say, okay, I could add all these numbers up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I know that's 30 out of 36. Or I could look and see what's more than 9, 1, 2, 3, 4, 5, 6, and then subtract that from 36 to give you 30 over 36. Dividing through by 3 would give me 10 over 12, and dividing both by 2 would be 5, 6. If I throw a fair coin and a fair dice, what is the probability I see a prime number or a tails? So I could say the probability that prime or a tail, I could just draw a sample space. So I could just list the outcomes, which is a sample space. So I could have list all the different outcomes. I can have a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6, or I could have a tail and a 1, tail and a 2, tail and a 3, tail and a 4, tail and a 5, and a tail and a 6. So I've just listed, I've gone through methodically and listed all the possible outcomes. So if I then go through those, I want a prime or a tail. So I've got a prime number there, so that's 1, 3's a prime, 2, 5's a prime, and then a tail. So that means all of these have got a tail in. So it doesn't matter whether they're prime, they've got a tail in. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes out of a total of 12, which would give me 3/4. I could draw a 2D sample space diagram. So going down my diagram, I can write the possible outcomes when I throw a coin, which would be a head and a tail. And going across, I can write out the possible outcomes on a die. So that's my other event. So 1, 2, 3, 4, 5, 6. And going across, I can write down my different combinations. So I can have a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6, and here a tail and a 1, tail and a 2, tail and a 3, tail, 4, tail, 5, tail, 6. So the probability I see a prime or a tail, I can go through the body of the table. A prime I can have 1, 2, 3 primes, 4, 5, 6, 7, 8, 9. And in this whole table, how many numbers are there altogether? There are 12. So 9/12, which is 3/4. Jack and Jill each have 5, 10 and 50p in their pocket. They each take out a coin at random. So without looking, they just put the hand in and pull a coin out. Draw a probability space diagram to show the different combinations. Well, the first number I'm going to put is going to represent Jack's, and the second number in my pair will be Jill's. So we could have a 5 and a 5, or a 5 and a 10, or a 5 and a 50. Or Jack could get a 10, and Jill could pick a 5. Jack could get a 10, Jill could pick a 10. Jack could pick a 10, Jill 50. Or Jack could pull out a 50 and Jill a 5. Jack could pull out 50, Jill a 10, and Jack will pull out 50 and Jill will pull out 50. So there we have our probability space diagram to show the different combinations. Tom has 3 pairs of jeans which are white, black and blue, and 4 t-shirts which are white, red, blue and black. List all the possible outcomes in a sample space diagram, and then find what the probability is that he chooses jeans and a t-shirt the same colour. So we can have a white and a white. We can have white jeans and a red t-shirt, have white jeans and a blue t-shirt, white jeans and a black t-shirt. Or we could have black jeans and a white t-shirt, black jeans and a red t-shirt, black jeans and a blue t-shirt, black jeans and a black t-shirt. You can have blue jeans and a white t-shirt, blue jeans and a red t-shirt, blue jeans and a blue t-shirt, and blue jeans and a black t-shirt. Now, in this whole body of the table, we have 3, 6, 9, 12 possible outcomes. So we want the probability his jeans and t-shirt are the same colour. So if we look in our table, we know there are 12 possible outcomes. So I know total is going to be over 12. And if we look at the table, we have white and white. We have black jeans and a black t-shirt. And we have blue jeans and a blue t-shirt. So we have 3 possible outcomes. Simple. So 3 outcomes where the t-shirt and the jeans are the same colour out of a total possible number of outcomes of 12, which is 1/4 when we simplify. So I'd like you to answer these questions in your so pause the video and answer these questions in your exercise book. So for question 1, if you're throwing 2 fair coins, so I'll have coin 1. I can choose a head and a tail. And on coin 2, I can choose a head and a tail. So I can have a head and a head and a tail and a head, and a tail and a tail. So the probability, therefore, of choosing a head and a head, well, there's only one chance out of a total of 4 possible outcomes. So the probability is 1/4. The probability of choosing a head and a tail, so just a head or a tail, or head and tail, Now it doesn't specify order here, so if we want the probability of a head and a tail, I've got two possible outcomes where I get a head and a tail. So that would be 2 out of a total of 4 outcomes, which is a half. So question 2, after throwing 2 die, fair die and adding, so I've drawn a sample space diagram here, and I've got my die 1 and my die 2, and I'm adding the totals together to get all the possible outcomes. So here I've got 6 and 1, that gives me 7, 6 and 2 is 8, 6 and 3 is 9, and so on. And so in the whole table here, just in the body of the table, there are 36 possible outcomes. So the first question I've been asked is that the total is prime. So how many prime numbers are in that table? Well, we know there are 36 numbers altogether. How many of them are prime? Well, we know 2 is a prime, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The probability would be 15 out of 36, and dividing both top and bottom by 3 would give us 5/12. For second question, the total is less than 4. Total less than 4 is just these 3 numbers here. So the total less than 4 is going to be 3 out of 36, which simplifies down to 1/12. And finally, the probability that the total is odd, all the odd numbers. So if I just get a different colour here, I'm going to circle all the odd numbers. So we've got they're odd, got all our 5s there, which are odd, all our 7s, and 9, and 11. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that'll be 18 out of 36, which is a half. Now in our fourth example, it says after spinning 2 spinners, one ABC, so spinner 1 is A, B, C, and spinner 2 is A, B, C, D. Probability you get both vowels, so I could have an A and an A, an A and a B, an A and a C, and an A and D. Make sure you keep your order the same. So I'm always starting with spinner 1. So BA, BB, BC, and BD, CA, CB, CC, CD. And the first question says the probability they are both vowels. Well, I've got 12 different altogether. So that's over 12. And how many are both vowels? So I've got A and A, that's 1. I've got B's not a vowel and C's not a vowel. So there's only one possibility of where they're both vowels. So 1/12. The probability. So the notation on this second one is probability greater or equal to a vowel. So there's at least one vowel in that. So that notation might have confused you. So probability that there's greater or equal to one vowel, at least one vowel. So we have 1, 2, 3, 4. So all the top row. We have BA 4, 5. and then CA is 6. So there's 6 out of 12, which again is a half. And finally, the probability, they have B and C. So we've got to have B and C in the combination. So B and C, we have one there. We've also got that combination there. So the probability they have B and C is 2/12, which cancels down to 1/6. In the body of the text. I would now like you to do the questions from exercise 12B, but check on Insight the questions I would like you to do. Remember to draw all your diagrams clearly to show all you're working out, and make sure your answers are written as fractions in their simplest form or as a decimal. Read the question and determine whether you want your answer as a fraction or decimal depending on the question. If they don't specify, then either is fine. But do not write your answer using words such as likely, unlikely, or as a percentage. I don't want to see any percentages or ratios such as a 1 in 2 chance. Answers must be as a fraction in its simplest form or a decimal. And check you're doing the correct questions from Insight, not necessarily the ones on this slide. So 12. And to finish off, I would like you to have a go at doing this question in your exercise book as well. See if you can match these up